Right now, we're counting down, but we're about to launch the largest flying object ever made. But this isn't on the radar for everybody, and we know that. So we want to kind of take a beat, pull back, do a little bit of Starship 101. To do that, I've got some special guests crashing the webcast today. Joining me now in Star Factory, Elon Musk, Chief Engineer at SpaceX, Bill Riley, our VP of Starship Engineering. Thanks for being here, guys. I know we got a rocket about to get off the pad, but let's start people off like high level. Like, why are we here? What the hell are we doing here?
Well, I don't know about everybody, but I'm here to try to build into the future that I imagined and dreamed of as a child, where starships with people are out among the stars exploring the universe.
Yeah, so the why, it's always important to explain the why of things. And the why of Starship is that we want to be a multi-planet species to extend consciousness beyond Earth, I think for two main reasons. One is to ensure the long-term survival and prosperity of life as we know it in consciousness, which if we are a multi-planet species and ultimately a multi-stellar species out there among the stars, the probability of survival is much, much longer. That's kind of the, defensive aspect or life insurance for life collectively. But then there also need to be things that are inspiring and exciting and that give you reason to live. Life cannot just be about solving one tragic problem after another. There must be also reasons to get up in the morning and be excited about the future. And a future where we are a spacefaring civilization is infinitely more exciting than one where we are not.
And we're doing it all pretty unique location. I mean, the pad's behind us. We got rocket on the tower. We got another tower with it. We're sitting inside Star Factory. And I mean, it wasn't like this for very long. This is all pretty brand new.
Yeah, I think we moved Starship here in about the early part of 2019. So we've been coming that entire time and seeing the site evolve from a double-wide trailer and a tent where we built Starhopper to the first suborbital test flights. And now we have behind us two towers for the first time as we build towards the first operational flight from the second tower at the end of this year. And this beautiful building, 1,000,000 square feet, where we're able to work towards a production line of Starships.
Yeah, the SpaceX team has done an incredible job of building out really the most advanced rocket manufacturing facility that has ever existed. This is far beyond any rocket fabrication facility that has ever been built. This is essentially alien-level technology, and it was all built here basically down by the Rio Grande River and close to the beach. It's an incredibly improbable location, and this used to be a sandbar. I think we're about, 3 feet or about a meter above sea level. It really was nothing. If you see the time lapse from sandbar to two launch towers and a gigantic rocket factory with high bays, and we're going to be building something called the Gigabay, which is like one of the largest enclosed volumes on Earth. So it's sort of like a gigantic Borg cube that we're going to be building here for building and storing these gigantic rockets. It's really spectacular, and anyone can come and visit. So because we're on a public highway and we're literally by a public beach, you can actually come and see the rocket. You quite close up. I mean, you can drive past it, and you can also look at the factory. And anyone could do this from anywhere in the world. So if you can come and visit and check it out. So I think it's pretty cool that it's
not right now.
Just not right now.
Just not right now.
Obviously not when we're launching because there's some safety issues. But the rocket's often just sitting on the pad without any propellant in it, and then you can just come here and visit. It's very easy.
Yeah, I think it's a really special place. Yesterday, the ship went down the road behind us, and I saw families outside on Sunday going for their Sunday stroll, and they were greeted by Starship going down. And I think that from the very beginning, the thing about Starship different than Falcon and other rockets that I'm aware of is we designed it to be mass-produced at scale. And it's not about building one Starship and getting to orbit once. It's about doing it in a sustained and rapid way.
Yeah, we're aiming for ultimately thousands of ships to be built per year, which is what's needed in order to construct a city on Mars that is self-sustaining. And the major fork in the road of destiny will be when the Mars city is capable of surviving, even if the resupply ships from Earth stop coming for any reason. And that reason could be something cataclysmic, or it could be that that civilization simply subsided. There's always this debate throughout history of will civilization end with a bang or a whimper. But either way, if the critical thing is to get to the point where Mars is self-sustaining and can survive even if the resupply ships stop coming for any reason, which means that you need to build an entire base of industry on Mars in order for Mars to survive. For example, it's not simply enough to build a chip, like a computer chip factory, but you need the ability to build computer chip factories. So this is going to really take a lot of tonnage. I mean, my guess is at least 1 million tons to the surface of Mars, and maybe it takes less than that, but it's going to be a lot. But this is a very exciting future. It's one which will ensure the long-term survival and prosperity of life and consciousness, and it's the critical stepping stone to get from this solar system to other star systems, and perhaps go out there and explore, and perhaps we'll encounter alien civilizations that maybe they're alive now, or maybe they enjoyed a period of prosperity for millions of years, but also died out millions of years ago. So it's humbling to think of the age of the universe, according to the standard model of physics, being approximately 13.8 billion years old. So an incremental million years would be 3 digits past the decimal point. And if you look at, say, our civilization and measure our civilization by the first evidence of writing, which is about 5,500 years ago, civilization as measured from the first writing is only 1/1,000,000th of Earth's existence.
Or blip.
Yeah.
Yeah.
Flash in the pan so far.
Yeah. Well, we're getting some cool shots. Rocket out on the pad right now. We tell people, like, come down, see it. It's hard to get, like, a sense of scale of just how massive this thing is. And we were able to catch somebody working on it a little while ago. And, like, part of the reason you said we're sending millions of tons, that's kind of why this
When
thing
I
is
think
so
in this
massive as
image,
it
Dan, you
is.
can actually see the person working at the bottom of the ship, and as we zoom out, you see the full ship, that sort of two-tone silver and black, and then the booster below it, right? And it really sets the scale, which doesn't come across, I think, other than in person. And when I do tours, I like to say Starship is real, Starship is big, and Starship is really big. And I think you can see there, and with the factory shots you saw earlier, again, we've got Flight 10 on the pad, but we got many more behind it.
Yeah, so I posted a video yesterday of just a brief scan of part of the Starship factory, and you can get a sense of the scale of the factory. Yeah, I guess we could talk a bit about why Starship is the way it is. Like, for example, why is half of the ship black and half of it is silver colored? And that's because the bottom half of the ship, the bottom as seen from orbital entry, has a heat shield on it. So the black there is the heat shield, and then the core structure of the rocket is a special alloy of stainless steel, and that's where you see the sort of shiny silver parts are stainless steel. The reason for steel over aluminum is that the heat of atmospheric entry and the heat of the rocket engines is enough to easily melt aluminum, but steel is much more resilient against both ascent heating, but especially the reentry heating. And you don't have to paint it, which is actually very difficult to paint a large object that is going through cryogenic cycles and have the paint stay on. It's quite challenging.
And so we've talked about it. It's massive. It obviously takes a whole lot of energy to make that thing move. And that's where Raptor really starts to come in. Most advanced engine on the planet. Giant
Yes.
lightsaber.
No, that's a lightsaber and a half. You would get vaporized in an instant if you were standing in front of Raptor. So, yeah, burnt to a crisp in less than a second. So in order to create a fully reusable orbital rocket, you have to advance the state of the art in every part of the rocket. That means the engines have to be better than any engine ever. The structure's got to be better than any structure ever. You've got to you've got to have a means of bringing the rocket back to the launch pad. You've got to have a fully reusable orbital heat shield, and that no one has ever made a fully reusable orbital heat shield. The space shuttle, for example, required 9 months of refurbishment between flights. So the space shuttle heat shield would come back essentially partially broken and would require many months of refurbishment in order to fly again. What we're trying to achieve here with Starship is to have a heat shield that can be flown immediately. So the ship, both the ship and the booster, would be caught by the tower arms, and the booster would be placed immediately back on the launch stand, and the ship's got to orbit Earth at least once, but then could be back potentially in one orbit, but in most cases several orbits. So the ship would come back several hours later, but then be caught by the arms and placed on top of the booster. You can also have multiple ships ready so that a single booster could service 5 or more ships, so that you could be flying the booster in theory, every hour. This is kind of a profoundly fast speed, obviously, for the largest flying object by far ever made. But it's the reason why we catch the booster with the tower arms, and the ship also will be caught with the tower arms, because that's the fastest way to get the booster and the ship back to flight. If we had instead put landing legs, which we have done before for the ship tests, we actually had landing legs that flipped out, and the ship we've successfully demonstrated landing with legs. But if you do that, if we were to do that with the booster and the ship, here we'd have to land somewhere else with the legs, then lift the rocket, stow the legs, transport the rocket back to the pad, which is very unwieldy when you've got a gigantic thing. Then it would be picked up by these tower arms and placed in the launch mount. That would delay the reusability dramatically, and would add a lot of mass with the landing legs. So that's why we catch the rocket with the tower arms, because it's the same tower arms that put the rocket in the launch mount are used to catch the rocket. And that means that we can put the booster back in the launch mount in less than an hour after liftoff. In fact, the booster is going to come back very fast. 5 or 6 minutes later, this booster is coming back one way or another, or not coming back. So then you really have propellant fill time, which can be brought down to about 30, 40 minutes. And that means it is theoretically possible to fly the booster again in less than an hour.
I think when I think about it, it's the jet drives up to the jetway, the people get off, new people get on, and it leaves. You don't want to land the jet on a different airfield and then tow it over to the jetway. So it's just operationally simpler and faster.
Yeah, we've had a lot of success with the booster, 3 for 3 on the catch attempts. When we bring it back, we've reflown one, so awesome. And then again, Starship superpowers, the whole thing is reusable. So ship reusability is like what we're working on right now. We've been able to get some really spectacular reentries on a couple of flights, hoping to get this one for reentry on the V2 ship. But yeah, that fully reusable heat shield, that thing that has just never been done before, that's one of the things we're really looking for that data on.
Yeah, I mean, there are thousands of engineering challenges that remain for both the ship and the booster, but maybe the single biggest one is the reusable orbital heat shield. We are confident in making a fully reusable orbital heat shield, but it will require many flights, many iterations to figure out where the weak points are in the heat shield, where we need to change the design, either strengthening the tile or changing how big the gap is between tiles, changing what's underneath the tile. There's 100 different variables that we could tweak with the ship tiles, the heat shield tiles. But the only way to know exactly what we should be adjusting is to fly repeatedly and be able to examine the ship upon landing. And we have successfully brought the ship back through the atmosphere and achieved a soft landing multiple times. So we know that this is possible, but we have in the process shed many heat shield tiles. So we need to be able to do this without shedding heat shield tiles, and do so repeatedly.
And I think what you're seeing now is the Starship. This is CG of it coming in and landing on the tower, much like the booster, but there's some additional challenges there where we need to make sure we don't scrape the tiles off as we slide along the chopstick
We can't
arms.
shuck the heat shield.
Don't crush the ship.
Rapid
Yeah,
reusability.
if we shuck the tiles, then that's obviously going to fail the reusability test.
So ships can use the tower to land and catch, like the booster here on Earth where towers are available. And for our initial landings on Mars and other planets, we'll need landing legs that deploy much like what you're seeing here with Ship 15 when we did our suborbital test to prove out the precision descent landing, which was a successful test. We actually landed two. One was we were able to actually recover it, and you can see it here in the rocket garden if you visit Starbase.
Yeah, so the rocket garden that Bill mentioned, we have actually a whole bunch of boosters and ships, and we'll be adding to them over time. So you can see an evolution of Starship just by driving down the highway.
Yeah. So reusability is key. There's some other technologies we're still looking to prove out. Really big one is going to be the on-orbit refilling. Looking to do that next year, and that's really what's going to kind of unlock, Starship going everywhere else, going everywhere beyond Earth. And that's something that's, again, never been done before, kind of like that reusable orbital heat shield, but it's going to be something that's kind of some of the other secret sauce to Starship, where we're going to be able to send hundreds of tons per ship to Mars.
Yeah, I like to think of it as if we get to orbit with a full cargo bay, but we're empty on fuel and oxygen. So basically, we're running on fumes. Then we send other ships to dock, transfer propellant, and now we made our two-stage rocket look like a many multi-stage rocket. And we get all of that performance, and we can take that full cargo bay now wherever we want to go.
Yeah, so a crucial technology that we hope to demonstrate next year is this orbital refilling, much like aerial refueling. It's essential for being able to send significant payload to Mars. So you essentially send a ship to orbit with a few hundred tons of payload, sort of a filled payload bay. But once it gets to orbit, the tanks will be mostly empty, and then you send up additional tanker ships to refill the Mars ship's tanks, so that it can thrust from Earth orbit to Mars and have enough propellant left for landing. So this is orbital refilling is also not something that's ever been demonstrated before. So that would be a brand new technology. We obviously have at SpaceX figured out how to dock repeatedly with the space station. So in a lot of ways, this is like docking, and in some ways it's easier in that SpaceX is docking with its own craft. But no one has ever demonstrated propellant transfer in orbit, to the best of our knowledge, and so this would be propellant transfer at a very large scale. And but with full reusability and propellant transfer, those are the key technologies needed for building a city on Mars. And I'm confident that the SpaceX team, which is incredibly talented, will achieve these goals. And we will be landing ships on Mars in the future and building life on Mars, building greenhouses and life on Mars, and ensuring the long-term survival of life as we know it. And it's important to note here that obviously, we are effectively stewards of life here on Earth. That the other creatures cannot build spacecraft and get to other planets. So if there were to be a cataclysmic event, like a giant meteor that destroyed the dinosaurs, or ultimately the sun will expand to envelop Earth and destroy all life. We know this is an undisputed fact. Then if we don't take life to another planet, all life will be destroyed. So it's incumbent upon us to ensure that we do bring life to other planets and ensure the long-term survival of life as we know it on planet Earth.